Here we go. Final thing for lesson 1, some good old-fashioned practice. You should really commit these to memory. If you have them committed to memory, it's an easy task. It's simple chain rule stuff. So here we go. The derivative of the inverse tangent of 3x, let's say of 3x squared. Well, the derivative of inverse tangent is 1 over 1 plus stuff squared. Now we have to do the derivative of the stuff. So this is times 6x. And that's how we're going to leave it for now. Let's take a look at the derivative with respect to x of the inverse secant of 5x. That's going to be 1 over absolute value of stuff times the square root of stuff squared minus 1. Okay, for now let's not worry about the simplification. The derivative with respect to x. We will eventually, but right now we're not. The inverse cosine of the sine of 2x. One of the things that people mess up on is we start doing the inverse trig derivatives and they forget that sometimes I'm not asking for inverse trig but regular trig derivatives. So the derivative of inverse cosecant of stuff. So that's going to be negative 1 over, the square root of 1 minus stuff sine 2x squared times the derivative of the stuff, which is cosine 2x times the derivative of mini stuff times 2. Okay, how about the derivative with respect to x of e to the 5x squared? E to the stuff. So the derivative of e to the stuff is e to the stuff times the derivative of stuff. Simple. Next, the derivative with respect to x of the natural log of inverse tangent of 3x. Now, I know I'm moving quickly, so try your best. Press pause at the end of each one of these and see if you can figure them out. Natural log of this stuff. The derivative of natural log of stuff is 1 over stuff times the derivative of stuff. And the derivative of inverse tangent 3x is 1 over 1 plus little stuff squared times the derivative of the little stuff times 3. Next, derivative with respect to x of 4 to the power of 5x cubed. A to the stuff. So the derivative is a to the stuff times natural log of a, and we can't forget the derivative of stuff, 15x squared. Next, derivative of e to the square root of x squared plus 1. It's kind of hard to see that's a squared. E to the radical x squared plus 1. Press pause, do it. E to the stuff. So the derivative is e to the same stuff times the derivative of that stuff, which you should recall, 1/2 this stuff to the negative 1/2 times the derivative of this stuff times 2x. Okay, moving on. The derivative with respect to x, secant squared, e to the negative 4x. Notice I did not say inverse secant, but regular, good old-fashioned secant. Pause. 2. Stuff to the 1, to the 1 power, times the derivative of this stuff, which is secant little stuff, tangent little stuff, times the derivative of the little stuff, which is e to the tiny stuff, times the derivative of the tiny stuff, -4. Nice. Okay, the derivative with respect to x of log of natural log of x. In the absence of a written log, it's assumed to be base 10. So what I like to do is just change the base in my mind. So this is going to be the natural log of the natural log of x over natural log of 10. There we go. I've changed the base to base e. So I'm going to factor out this 1 over natural log 10. Then I'm going to take the derivative with respect to x of natural log of x. Tongue twister. 1 over natural log 10 times 1 over, whoa, that does not look like a 10. Now we're to this derivative. 1 over natural log of stuff times the derivative of that stuff, which is 1 over x. Kind of a fun, tricky one. Derivative with respect to x of 10 to the power of sine x. So this is going to be a to the stuff, natural log a, derivative of stuff. How about the derivative with respect to x of 10 to the inverse secant of x? 10 to the inverse secant of x, natural log of 10 times 1 over the square root of 1 minus x squared. Last example. The derivative with respect to x, x squared times e to the cosine of x. Let's not please forget product rule. First term times the derivative of the second, e to the stuff times negative sine x, plus second term times the derivative of the first. So in the practice problems here, I did not simplify, nor did I talk about the domain issues. What I'd like you to do for the homework is I'm going to give you some odd questions. I want you to have them unsimplified. I will write out solutions for the unsimplified version, but I would like you to try to get the answer that is displayed in the back of the book. The reason is, a lot of these will show up on the AP exam in the form of a multiple choice question. So it is in this unit that it is very important to try and simplify. So do that in the homework. Get your answer unsimplified first, and I will have solutions for those. But then I do want you to try hard to make it look like the answer in the back of the book. There are different ways to simplify, but see if you can simplify your answer so that it matches.